whether the third median, this median is the center, and here the vertex, 4 like this, you get another median, third median. What I wonder, the 3 medians, they intersect at one point, that is called G. This is called centroid. Previous triangle is a right angle triangle. Now here we can take an acute angled triangle. In this you can see, same method, you find the midpoint, then join the opposite vertex. So now I have drawn a median. Same thing, here you fold like this, by that you are getting midpoint. Join this midpoint to the vertex. Now you can see they intersect G. Now let us verify whether this another median, the third median, will pass through this or not. Midpoint, opposite vertex, then I got the median. Now see clearly these 3 medians intersect G. This is found for the acute angle triangle. Now here the same thing we have done for right angle triangle. Method is find the midpoint of this side, fold like this, opposite vertex, 1. Similarly find the midpoint of this side, like this, then fold the median, second median over, now third median, find the midpoint, now join the vertex. Now you can see the meeting point of the 3 medians, which is called center of the triangle. We are going to find the circumcenter of a given triangle. Now take this triangle, you draw the perpendicular on each side. How to draw that? You take this end to the other end, crease it, that's all. Now you have found or you have drawn perpendicular line segment to this line. In the same way, take this line segment, that is this side, fold like this. Now again we have drawn one perpendicular face of this side. Take the third side, fold like this, then crease it. So now you can see we have drawn 3 perpendicular bisectors to the sides of the triangle, and they intersect one point, namely S. This is called the circumcenter of the triangle. Instead of this acute angle triangle, we get right angle triangle. We can see one wonderful thing is happening. The method is again same method. Take this to this, fall on this, then fold like this. Now we have drawn the perpendicular bisector of the line. Now here also fold like this. We are getting the perpendicular bisector of the line segment. Then take the third side. Here is the third side. Draw the perpendicular bisector of this line segment. Say fold like this. Folded. Now you can see all the 3 perpendicular bisectors, they fall on one line, that is called line segment, it's called hypotenuse. And you can see it is exactly half. So this circumcenter in a right triangle falls on the hypotenuse, and it is the midpoint of the hypotenuse. Now we have taken one obtuse angle triangle. Let us draw the perpendicular bisectors of the sides. I have drawn one perpendicular bisector, then another perpendicular bisector line. Now third bisector, so now you can see all the perpendicular bisectors, they do not intersect inside the triangle, so the point is outside. So in an acute angle triangle, the circumcenter is inside the triangle. The right angle triangle, the circumcenter falls on the midpoint of the hypotenuse. In obtuse angle triangle, the circumcenter falls outside the triangle. Now we are going to find orthocenter of a given triangle. What is orthocenter? It is the meeting point of the altitudes of each side passing through the opposite vertex. Now you can see I have taken this point, draw erect a perpendicular line to this passing through the vertex, opposite vertex. I have drawn now one perpendicular line. Similarly draw another perpendicular to the other side passing through the opposite vertex. Now we have drawn two. These are altitudes. Similarly you can do for this side. So for each side we have drawn perpendicular line passing through the opposite vertices. So this is one altitude, another altitude and third altitude. They meet at one point, that is O. The O is called orthocenter. So the orthocenter meeting point of the altitudes of a triangle. Another wonderful thing is we have taken now a right angle triangle. In the right angle triangle you can see only one side is to the other side. So this is this vertex, so falls to the other. Similarly here, so this 90 degrees, one is one altitude and another altitude. But it is only necessary for us to draw the altitude of the other side. Okay, drawn. And now you can see the orthocenter. So in a right angle triangle, the orthocenter is the vertex where 90 degrees is formed. The vertex, this is 90 degrees. The vertex at this is called O in a right angle triangle. We are going to demonstrate how to find the incenter of a given triangle. This is a triangle we have taken. The incenter is the angle by meeting point of the angle bisectors of each angle of the triangle. Now here is one angle. Now I have to find the angle bisector of the line and the angle bisector of the angle. So now it is bisected. Similarly for this angle, see, very clearly done it. So over 2, then third. They meet at one point and that point is called incenter, I. So the incenter is the meeting point of the angle bisectors of each angle of the given triangle. There I have taken only acute angle triangle. Now let us try for this what I call obtuse angle triangle. Method is same. Angle bisector 1, angle bisector 2, angle bisector 3. Like this beautifully they pass through one point and this is called incenter. So what is incenter? The meeting points of the bisectors of the angles of the triangle. Now we are trying for right triangle. Same method. See here bisector. This angle is bisected into two halves. This angle is bisected into two halves. Then this angle is bisected into two halves. So you can see all these bisectors, they meet at one point, that is called I, incenter. chapter 6. In this case, we have seen a square. In a square, opposite sides are equal or all the sides are equal, and one angle is 90 degrees. That means this angle 90, this also 90, so 90, 90. So all the angles are equal, measuring 90 degrees, all the sides are equal. This is a square. And this is an example for a rectangle. Here we call this length and breadth. Here opposite sides are equal. This is equal to this and this side is equal to this. And one angle is 90 degrees. Those is called a rectangle. Now this represents a parallelogram. You can see opposite sides are parallel. Now not opposites are equal. This opposite is only equal. You can see opposites equal, but not one angle is 90 degrees. See here, opposites are parallel, opposites are equal, but one angle is not equal to 90 degrees. Therefore, it is parallelogram. If one angle is 90 degrees, it becomes a rectangle. So, this is an example for parallelogram. Now, here is a beautiful example for this rhombus. In rhombus, you can see all sides are equal. Number 1. Number 2, opposite sides are parallel, but opposite angles only equal. Opposite angles equal. The diagonals, they bisect each other at right angles. So one is the perpendicular of the other. So it is called a rhombus. Now you would have seen the kites flying in air. This is called an example of kite. These opposites are, these two sides are equal, adjacent sides. This is equal, but not equal. The adjacent sides are not equal. They intersect at, the diagonals intersect at 90 degrees. So this is an example for kite. In this quadrilateral, the opposites are parallel. You can see they are parallel, but the sides are not equal. Only this, only opposite, only one pair of sides are parallel. This is called a trapezium. In the USA, they call this trapezoid. Here, this is called a quadrilateral. Nothing is equal. All sides are different. All angles are different. This is called a quadrilateral. Now, a wonderful idea has happened. This project is called the ever-present parallelogram. The ever-present parallelogram. Find the midpoint of this side over. Find the midpoint of this side over. Find the midpoint of the said side. So the third side. Now find the midpoint of the fourth side. Now we have formed the midpoints of each side of the sides of the square. Now we are going to join or fold through these two midpoints. Similarly, I am going to do like this. For the third. Now you can see we have got one quadrilateral. There you can see opposites are parallel. Therefore, it is a parallelogram. But in this case, you are getting a square. Of course, square is a parallelogram. It's also a parallelogram. Rectangular sheet of paper. We are going to do the same thing. Now, first find the midpoint of this length, the midpoint of the opposite length. So now for the midpoints. Similarly, for the breadth, you find the midpoint for the opposite path. Now see, I form the midpoints of these lengths and this plus. Join regularly this, that is fold like this, are in order. 1, 2, 3, and then 4. See, here also we are getting one parallelogram, but the idea is here, even though it is a parallelogram, it is a beautiful rhombus. You can see how. If you fold through this point, one, and the opposites, actually one diagonal is the perpendicular of the other diagonal. One diagonal is perpendicular to the other. So this figure is called a rhombus, but it is a parallelogram. So this is a parallelogram. We are going to the same thing. Find the midpoint of the each side. 1. See, very easily we are finding the midpoint. We are not measuring. See, I am getting it. Pinch here. Similarly, so I form the midpoints of each side of the parallelogram. We are going to join the consecutive points. 1, 2, 3, 4. Now here we are getting a beautiful parallelogram. This is an example for rhombus. We are doing the same thing, that is find the midpoint of the sides. I have done this side to the second side. Third side. See, very easily we are getting the midpoint. Fold like this. Then should be very careful. To go wrong, you have to take another paper. That's all. As usual, as we done before, join the midpoints in order. 1, 2, 3, and then finally 4. Now here you can see you are getting a beautiful rectangle. Upper sides are parallel, upper sides are equal, and one angle is 90 degrees. So in a rhombus, if you do like this, you get a rectangle. But rectangle is also a parallelogram. Now this is an example for kite. We are going to do the same thing. Find the midpoint by folding like this, bringing these together, pinch it. 1, 2, 3, 4. Now as usual we are joining the midpoints consecutively. 1 over 2 over. I have finished 3. Now I ended with the 4th one. Here also we are getting a beautiful rectangle. Here also, because this 90 degrees, this becomes 90 degrees. Opposites are parallel or opposites are equal. Now this is an example for a trapezium. In the USA they call this trapezoid. We are doing the same thing. Take this vertex, make this to fall on the other vertex. Now pinch it. Now we found the midpoint. Take this, make this to fall, pinch it. Take this vertex, make it to fall on the other vertex. Pinch it. 2 vertices join together. We have fall on the side, pinch it. So do the same thing. That is, I'm joining the midpoints in order. So the 4th one. Now here also you can see you are getting a parallelogram. In trapezoid also or in trapezium also you are getting a parallelogram.